Okay, so which number was it on the weekly assignment?
Number 3, I think it is. Yeah, that one. It's like there's a force going into that roller.
Number 3 on the daily problems? 3 and 4, is that what I've heard so far? Sure.
Because we don't know what the angle is.
Mhm.
And it's not just going to be. It's not going to be perfectly straight in the x-axis or the y-axis.
Right, that's right. But I think you can. I haven't done that yet, but I think they give you enough geometrical information that you can figure that out. It's like the SATs all over again.
Professor,
Yes.
for the moment, like it doesn't, like the fact that it's like on AB, does it even matter really?
That's a good
Because
question.
through the whole
So
thing,
no,
right?
once you are treating something as a rigid body, it does not matter where a couple acts. It does matter when you're treating it as a deformable body, which we never do in this class, but we will in deformable body mechanics. But yeah, for our approach, that could be anywhere, and the answers would be the same.
Yeah, for number 3, you just need to use the distance from the origin to the direct, right? Because it's 8 away from the end.
I'm sure you can just do it with trigonometry, but okay. So the daily assignments that we're on is centroids, and we're doing 3 and 4. Oh my God, look at that thing. That's so hideous. One thing about centroids is you look at it and it looks simple, and then it always ends up being so much more time consuming than you think. What happened here? Okay. So, and this is the one where the semicircle thing comes up. Is that right?
Yeah.
So okay. So let's think about. So you know that a quarter circle has a distance to the centroid of 4r over 3 pi. And so now let's think about a semicircle. Well, you know this is a line of symmetry, so you know it has to be right along the middle there. But what about the y value? So we'll break this up into 2 pieces, 1 and 2, and think about the sum formula. So for piece 1, the area is pi r squared over 4. And the y centroid for 1 is 4r over 3 pi. For piece 2, the area is pi r squared over 4. Y2 is 4r over 3 pi. The total area is the sum of those two, so pi r squared over 2. And now the y centroid for the semicircle is the reciprocal of the total area, so that's 2 over pi r squared times the area of the first one times 4r over 3 pi plus the area of the second one times its centroid 4r over 3 pi. And let's see, you get a bunch of cancellations. Cancel, 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 cancel. The 4s cancel. And you come out with 2 over pi r squared times r cubed over 3 plus r cubed over 3. So that is 2 oh, what? Yeah, you can, so yeah, we'll simplify that. So 2r cubed over 3, and that gives you 4r over 3 pi. So anyways, usually, so if anytime the shape that you're looking at can be broken up into shapes that you know, you can use that sum formula to figure it out. Okay. Yeah, well, it really looks just like the integral formula. It's just the finite version. So it just says xy, if we're working in the plane, which we, in the plane, which we usually are, is equal to 1 over the total area times the sum of the centroid of the ith piece times the area of the ith piece. And so anytime you can break up a complicated shape into simpler shapes, you can use this sum formula. That's what I did here. Except I didn't do it with both components because we already knew what the x component was going to be of the centroid. Yeah, but then you just have to use volumes instead of areas if it's in 3D. Otherwise, it's just the same. Yep. Okay, so let's break this up into, let's say we have this big outer semicircle. I'm going to call that 1. And then we have this right triangle. I'm going to call that 2. And then I'm going to subtract the smaller, it doesn't go that way. Subtract the smaller semicircle. So that's going to be my 3. And I'm going to use a coordinate system here. All right, and for dimensions, so this, is 2 meters. That means the radius of this outer one is 1 meter. The radius of this inner one is 0.75. And the base of this triangle is 1. All right, so let's start putting this together. So semicircle 1 has an area of pi times 1 squared over 2, so pi over 2. And in that green coordinate system, the x centroid location is it's going to be negative 4r over 3 pi. R is 1, so that's just 4 over 3 pi. And then for y, we can use the symmetry, so that's just going to be 1. Any questions about that? I guess I'll put that in a decimal form. Well, we know that, so what we just figured out here is that the centroid of a semicircle is along its axis of symmetry, and from the base to the centroid is a distance of 4r over 3 pi. So for us, since the base is over here on the right, we're going 4r over 3 pi to the left from there.
So that's why it's negative?
Yeah, because of where my origin is. If you put your origin somewhere else, you'd get a different location, but okay, so negative 4 over 3 over pi. So we get negative 0.424 positive 1. And now we'll go to the triangle, piece 2. The area of a triangle is base times height over 2. So that is 2 times 1 over 2, so just 1. Bless you. And now the centroid of that we know that in the x direction, it's going to be 1/3 of the way. So with whatever direction you're looking at with a right triangle, there's a edge side and a point side. Okay. And the centroid of a right triangle is always 1/3 of the way from the edge side toward the point side. Okay. Or 2/3 of the way from the point side to the edge side. So we're going to go 1/3 of this length of 1 from here to there. Since that's where I put my origin, that's just going to be an x value of positive 0.3, but 0.3 repeating, 1/3. And now we have to do the same thought process for the y direction. So if you're going from the edge toward the point, you're going to go 1/3 of the way, so that whole way. The whole way is 2 meters. So 1/3 of that is 2/3. and that's in the positive y direction. So this is 0.6 repeating. And then the last one is the one we're removing. So this one has a radius of 0.75. So the area of 3. Remember, if we're removing material, I always think of it as a negative area. So this is going to be negative pi times 0.75 squared over 2. So that's negative 0.884. I guess I didn't put this as a decimal. Pi over 2 is 1.571. And now the centroid, this is the last thing we need. The centroid for that removed semicircle. So for x, we're going to go 4r over 3 pi in the negative x direction. And then in the y direction, we're going to go half of the distance of 1.5, but first we have to go up. Let's see, this would be 0.25. So it's going to be 0.25 plus 0.75, and well, that has to be 1 because this has an axis of symmetry right at the halfway point. So,
So for that one, I understand this 0.25, but then why did you add the whole 0.7?
because before, so it's 0.75 from the bottom of the semicircle to the centroid. But where the origin is, you have to go up 0.25 before you even get to the bottom of the semicircle. Okay, because it's not just the distance from an edge that matters, it's the distance from your origin that matters. Okay. So this is negative 0.318 for x, and then 1 for y. And now we can put these all together. Well, let's do the total area. So we got 1.571 plus 1 minus 0.884. So that's 1.687. And so the centroid of the whole thing is equal to 1 over 1.687 times 1.571 times the vector negative 0.4241 plus an area of 1 times a vector of 0.3 repeating 0.6 repeating minus an area of 0.884 times a vector negative 0.318 positive 0.1. And your calculator will do this. And I got that the centroid is at negative 0.031, positive 0.802. Or in other words, so
Professor?
yes.
So if we chose a different about point, like I just chose for all my problems, I chose the top left.
Mm-hmm.
So like that corner where
Yeah, you'll get different answers, but they
But, yeah,
physically all mean the
I
same
got
thing.
the same like answer,
Yeah.
like location wise.
Right. Any other questions about that?
If 1.571 is just b over 2, right?
Yeah, that's right. Okay, and then the next one. Number 4. Yeah. What the? Oh, just went to the wrong place. Okay. So this one is just about like the only reason you need to use the centroid thing at all in this one is to find where the weight force applies. This has a mass of 200 kilograms. So I'm going to start out by just drawing this shape and calculating the centroid. And I think you can often save yourself a little bit of headache by thinking what would be a useful location for the origin to be once you start the problem. I'm going to put my origin here, where that pin is. And I am going to break this up into 2 rectangles. I guess I'll do it this way. So okay, my rectangle 1 has an area that's equal to 0.3 times 0.2, so 0.06. And the centroid location is So for the centroid, we just have to go over half of the length of 1. So that's 0.15 and then 0 because the height is the same as our origin. And then for rectangle 2, the area is 0.2 times 0.2, so that's 0.04. And the centroid, well, we have to, so the centroid is 0.1 meters from the left side of this rectangle. But before we get to the left side of the rectangle, from the origin, we have to go 0.3. So this is going to be 0.4 in the positive x direction. And then, yeah,
They both have a thickness of 0.2.
Yeah, it's 0.1.
I was thinking the same thing. I think the first one should be 0.1.
oh yeah, you're right. You're right. So that's 0.04. This one is 0.03. Yes. Okay, so the x centroid is 0.4, and then for y, so we're gonna, from the top, the centroid of this thing is 0.1 because it's right at the middle. This is 0.05 down from the top. So it's just going to be 0.05 from the origin to the centroid of that second rectangle, and that's in the negative y direction. And the total area is 0.07. So the centroid of the whole thing is 1 over 0.07 times 0.03 times the vector 0.150 plus 0.04 times the vector 0.4 negative 0.05. And I get 0.293 for x and negative 0.029 for y. And now we can do a free body diagram. We have a pin joint at where I chose the origin. We have a cable force at that end, and then we have the weight force at the location that we just figured out. So the pin joint, we have a vector r. We have this weight force that's acting like there. And this thing has a mass of 200 kilograms. So 200 times 9.81 is 1962. And then we have the cable force Call that T. And I'll go rho, force, moment. The R vector has 0 rho vector. The force is Rx, Ry. Cross product is 0. Then we have the weight force, and the location of that, the rho vector for that is the location that we just came up with. Since my about point is the origin here. The force is 0, negative 1962. And the cross product is negative 574.87. And now we have that cable force. The location of that is, so that is 0.5 for X, negative 0.05 for Y. And now we have to figure out the unit vector for that force to represent the force vector. So that goes up 0.2 and over 0.4. So our U vector is 0.4, 0.2. A unit vector in that direction is 0.894, 0.447. So the force vector is 0.894 t, 0.447 t. And so the cross product of those two is 0.268 t. So now Newton's second law says Rx, Ry plus 0, negative 1962 plus 0.894 t, 0.447 t is equal to zeros. And then the moment equation says negative 574.87 plus 0.268 t is equal to 0. And so t is 2145.04 newtons. And R, the X component is negative 1917.66. And the Y component is 1003.17. And those answers would have been different if our centroid location was somewhere else. Yep.
How do you do, well, you pick your axis at right at the pin and join, but how did you know it was 0.05 on the Y?
Yeah. Okay. I don't know. I only know because I'm the one who drew this problem and I was lazy when I drew it. In these figures I make, if something looks like it's at a midpoint, it's at a midpoint, if it doesn't say anything else. So I know that this pin is halfway down here. Okay.
Yeah.
And this is 0.1 meters, the whole height of it. So halfway down is 0.05.
Mhm.
So how about why is the first rectangle it's 0? Like
The height?
yeah.
Yeah, because that pin is at the middle of the height and the centroid is at the middle of the height. So they're at the same height.
Yeah, so you don't go up or down
Right,
or down.
right.
So here, but like,
Like
the
I-
exam you'll tell us exactly, right?
If what?
In the exam, you'll tell us like.
Yeah, if I ever don't tell you something like that, feel free to ask me to clarify. But I do tend to be a little more careful on exams than,
Okay, so,
yeah.
thank you.
But like to do that, I would have had to like make a little thing like this and make it say 0.05 and adjust the
Yeah.
font and change I'm just gonna try to make it look like that's where it is.
Okay.
Any other questions?
Did you just go, so I can see it again, but
Mhm.
again.
Yeah. Could you please explain how do you find the vector of attention?
Yes.
0.4 and 0.2.
So there are always two ways to do this. There are two ways to do it. One is to figure out the angle and use cosine and sine. That only works in 2D. It really never works in 3D. In this case, but the other way that always works in 3D and sometimes is useful in 2D is to first figure out a vector that points in the direction you want, which would be, in this case, a vector from, so that would be a vector that goes from this point to this point, and then find the unit vector that's in that direction by dividing by its magnitude. So that's what I did. So to find the vector that goes from here to here, I said it goes in the positive x direction, 0.4, and it goes in the positive y direction, 0.1, and another 0.1. So that's the 0.4 and 0.2. And then I use the unit v function on my calculator. If you don't have that, you just have to divide it by the square root of the sum of the squares.
Thank you.
Any other questions? Okay, well, let's stop there. Long weekend. Woo! I don't think I have any homework I can give you either, so you guys are in luck.
Woohoo. Thank you.